Hello, welcome back. Learning here with us here at MPB. I am Miss Killen. We are in Unit 6. We are still in that Introduction to Quadratics. We are looking at Lesson 7A, completing the square to solve quadratic equations. I can solve a quadratic equation by completing the square. We are looking at standards REI for A and B. So we are looking specifically where A equals 1. So let's look at some of these notes. We need to take these notes. We need to make sure that we have these on our notes page. There will be times you can't solve a quadratic equation by factoring. We've seen that so far. But we can rewrite the equation so that we can complete the square. Then we can factor and solve as normal. So let's go ahead and see what we're talking about. So first of all, I want us to look at this. It says, how can we? First, we need to determine what number can be added to the equation to make a perfect square trinomial. Well, obviously, we need to ask what can be added to this equation to make a perfect square. Well, let's see. We've seen this equation before, and what did we have? We had a 9. Exactly right. Because 9 is a perfect square. When we factor it, when we get the perfect square as a 3, 3 plus 3 is 6. So that's how we are using these. So let's look at some more problems and see how we're going to apply this. All right? It says there are not any factors of 3 that will add to be 8. We can see this because all we have is 3. So what we're going to do is we're going to add something to this constant that we can find factors that will add to make 8. So if I add 13 here, I get a 16. 16 is a what? Perfect square. So I know my perfect square would be 4 and 4. 4 plus 4 is 8. So therefore, we get our ending result. So that is a very condensed version of how we're working with these. So Ms. Killen, I get that. I get I have to add something to my constant that's going to make it a perfect square. And that perfect square has to either add or subtract, depending on what I have, to get me that middle term. But I need a little bit more practice. Okay, a lot of this stuff, the more we practice, the better we're going to be. So let's do some practice on this. Let's see what we've got. So I've got y squared minus 22y minus 71. So I'm asking myself, what can I add that when I take the square root and get a perfect square, I can subtract to get that 22? So let's see. If I added 192, I would have y squared minus 22y plus 121. All right, so now I have y squared minus 22y plus 121. Well, I notice that 121 is a perfect square. So when I take the square root of that, I get a what? 11. 11 plus 11 gives me 22. So I can write y and y, minus and minus, 11 and 11. So I have y minus 11 squared. So this is how we are having to add something to that constant to get a perfect square. So I can take the square root and take those doubles and get that middle term. That's what we're doing here. So let's look at some more. All right, steps of how to do. All right, so here we go. When we use ax squared plus bx plus c, and c is not a perfect square, we can use completing the square. All right, so what does that look like exactly? It's right here. I am moving the old c out of the way to make room for the new c, is basically what we're doing. I move my old c. To get the new c, I take b, I divide it by 2 and square it. And that's my new c, and I'm going to add it. Then I'm going to factor my trinomial and solve for my x. So let's go ahead and do this. I have ax squared plus bx plus c equals 0. So I'm going to move that c. So I'm going to have x squared minus 10x plus my new c. Now, when it says to move it, I'm going to do the opposite operation and get it on the other side of my equal sign. Here we go. Now let's remember, whatever I do to one side of my equation, I always, always, always have to do it to the other side. We don't ever want to forget that. What I do to one side of the equation, I have to do it to the other. So let's see. I'm going to take, where it says right here, I'm going to take my b, divide it by 2, then square it. Negative 10 divided by 2 is negative 5. Negative 5 squared is a positive 25. Whatever I do to one side, I do to the other. And then I'm going to rewrite. X squared minus 10x plus 25 equals 28. So now, for me to get that x by itself, I'm going to have to factor that trinomial. So I'm going to build my two binomials, taking the factors of this that add to give me the negative 10. It's going to be x and x, subtraction and subtraction, 5 and 5. Now, we've learned that if I have something that's the exact same that's multiplied together, I can write it how? As being squared. So let's do that. X minus 5 squared equals 28. So I have to get that x by itself. To get that square moved first, I'm going to take what? I'm going to take the square root. So let's do that. And I'm taking the square root of both sides. So I have x minus 5 equals the square root of 28. I want to get that x by itself first, so I am going to add 5 on both sides. So x equals 5. Now, 28 is not a perfect square. So I'm going to factor, if I can, perfect squares out from under the radical. So let's see how that works. So I take square root of 28. I have 7 and 4. 7's a prime number, but 4 is not. It factors to 2 and 2. There's my doubles that I circle. My doubles come out as positive or negative 2. 7 stays under my radical sign. So the answer to this problem, x equals 5 plus or minus 2 square roots of 7. That is my answer. It's a complex answer, but it's an answer. And we've used all the information from our past 2 and 3 lessons to get us to this point using perfect squares, factoring out from under the radical. So let's look at some more questions like this. It says, let's try one more. So I put a scale up here to tell you that we always have to keep these equations balanced. Whatever I do to one side of that equation, I have to do it to the other side. If I'm adding something to one side, I'm adding it to the other. If I'm subtracting it from one side, I'm subtracting it from the other. You have to keep these equations balanced. Think of it as a scale. So let's work with this one with this in mind. So I've got x squared plus 12x plus 31 equals 0. I can't factor it normal because 31 is prime number. So I'm going to move my old c. Well, Ms. Killen, how do you know it's your c? Because I put my labels up here. So I'm going to move, doing one and the other side, x squared plus 12x, making room for my new c equals a negative 31. Now, how did we say to get that new c? I take b, divide it by 2, and then what? I square it. So let's do that. I'm going to take b, divide it by 2, and square. 12 divided by 2 is 6. 6 squared is what? 36. Now, I just added 36 to the left side. So what do I need to do to the right side? I need to add 36 as well. So let's rewrite this. X squared plus 12x plus 36 equals what? You're right. So now, I need to go ahead and start the process of getting that x by itself. So I'm going to factor the trinomial part by making two binomials. I'm going to have my x and my x. The factors, 36, that add to give me 12 is going to be my plus 6 and my plus 6. I am multiplying the same things, so I am going to have x plus 6 squared equals 5. Isolate that variable, so I'm going to take the square root of both sides. I have x plus 6 equals the square root of 5. I need to get I need to get x by itself, so I'm going to subtract 6 from both sides. So x is going to equal -6. Now, that square root of 5, 5 is a prime number. So I can't even factor anything out because it's only got 1 and 5. So whatever the square root of 5 is, it's either going to be a positive or a negative. So Ms. Killen, how are you going to put that on there? I'm going to show you. So my answer is x equals -6 plus or minus the square root of 5. So Ms. Killen, are you telling me that sometimes I'm not going to be able to factor something out from under the radical? Exactly right. Sometimes you're just going to have to leave it in that form because you're not going to get whole numbers that you can bring out. Now, sometimes it may say give an estimate in round 2, so then you can go into your calculator and get some type of decimal symbol or decimal sign. But right now, we are just using the whole number, so we have x equals -6 plus or minus square root of 5. Let's look at some more. Let's do some practice. So I have 3 problems here. I am going to complete my square to do all 3 of these problems. So let's go ahead and get started. I'm going to move my old c's and rewrite x squared minus 4x, room for my new c, equals 32. To get my new c, I take b, divide it by 2, and square it. So I have -4 divided by 2 is -2 squared. That's going to be a +4 on both sides. Rewrite x squared minus 4x plus 4 equals 36. I want to get those x's by itself, so I'm going to factor. Make my 2 binomials. Factors of 4 that add to give me a -4 is x minus 2, and then x minus 2. I have the same thing being multiplied, so I'm going to write it in a shorter form. All right, get that x by itself, so I'm going to do the square root on both sides of my equal sign. X minus 2 equals plus or minus 6. Cannot forget that, plus or minus 6. Then I'm going to add 2 to both sides. So x equals 2 plus or minus 6. Now, when I get to where it looks like this, I can go ahead and do that math. I can give you an exact this or this. Ms. Killen, how to do that? Let me show you. It's going to look like this. 2 plus 6 or 2 minus 6. So my x is going to be 2 plus 6 is 8. 2 minus 6 is -4. So how I'm going to write that is x equals -4, 8. So I added the square root, and then I subtracted the square root. And that's how I got -4 and 8. Let's see what the middle one has. Let's see how we're going to have to work it. So I'm going to equal it to 0, move my old c, make room for the new. I'm rewriting. To get that new c, I'm taking b, dividing it by 2, and squaring it. -10 divided by 2 is -5 squared is 25. What I do to one side, I have to do to the other. X squared minus 10 plus 25, put that x there, equals. Now, 36 plus 25 gives me what? 61. There you go. All right, so I'm going to build my binomials. I'm going to have x and x. Factors of 25 that add to give me a -10 is going to be that -5. So I'm going to write that as a squared. So then I am going to take the square root to get that out of the way. So x minus 5 equals plus or minus. 61 again is a prime number, so I'm just going to leave it as plus or minus the square root of 61. And then I'm going to add 5 to both sides. So my x equals 5 plus or minus the square root of 61. Good job. Now this last one. It should have an f there. Ms. Killen has apologized. We use x's so much, I put an x, so it should say f squared minus 4f minus 60 equals 0. So let's go ahead and get our new c. To do that, I'm going to add 60 to both sides. And I have f squared minus 4f getting way for my new c equals 60. To get that new c, I'm going to take that b, which is -4, and divide it, and then square. -4 divided by 2 is -2. -2 squared is a +4, adding 4 to both sides. So I have f squared minus 4f plus 4 equals 64. Want to isolate that f. So I'm going to factor that trinomial. So I'm going to build two binomials, f and f. Factors of 4 that will add to give me a -4 is going to be that -2. I see that I'm multiplying the same thing to itself, so I'm going to write it as a square. I'm going to take the square root to get that square gone, and I have f minus 2 equals plus or minus 8. You're right. Still got to get that f by itself, so I'm going to add 2 to both sides. So f equals 2 plus or minus 8. So 2 plus 8 is 10. 2 minus 8 is what? -6. So there is my solutions. All right, so we've seen multiple ways to do this. We've seen multiple ways to use that square root. So now is time that we are going to look back to see what we've done. And even though when I can't factor an equation, I still need to see if I can use those perfect squares. I always want to make sure when I'm adding my new c, I can add it to both sides. To find that new c, I'm taking the b and I'm dividing it by 2, which will be that new c. And sometimes when you get that square root, you're going to get a whole number. So instead of having a plus or minus a square root symbol, you're going to get an exact number depending on what is under that radical. I'm so glad you came here to learn with us here at MPB. I am Miss Killen. Have a great day.